Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The book contains 230 problem solving questions. It has 174 data sufficiency questions. We have solved all of these problems already. If you're interested in watching the original solutions to any one of these problems, you will find the original solutions from day number 1 through 250. Right now we are in the process of redoing the problems. We are on page number 277. Today is our lesson number 266. Problem number 32 is what we're going to be working on. Problem number 32, it says, problem tells us that A and B are positive integers. We are told that A and B are some positive integers, and the question simply is their product even? Is their product even? In the first statement they tell us that A plus B is odd. Let's see what we can do with it. A plus B, we are told, is odd. Let's see what we can do with it. If A plus B is odd, well, is it possible for both of them to be odd? Odd plus odd, as we know, 1 plus 3 is going to be 4. Odd plus odd is even. Is it possible for both of them to be even? Even plus even, as we also know, is even. Which means these two integers A and B, because we are told that their sum is odd, we know now that they cannot be both odd, nor can they be both even. One of them has to be even, the other one has to be odd. Odd plus even is going to give us odd, or even plus odd. One of them has to be even, the other one has to be odd. Now let's see if we can answer that question. Is their product even? Well, if one of them is odd and the other one is even, odd plus even, odd times even is even. There you go. Odd times even is even. The question is their product even? The answer is yes. The answer is yes, their product is even. Again, the point here is not that the answer turned out to be yes. The point here is that we are able to tell definitively whether or not this product is even. And it just turns out that it is even. The first statement by itself is quite sufficient. AD, BCE. AD, BCE. Because the first statement turns out to be sufficient, we know now the answer cannot be B, C, or E. It will have to be either A or D, the final answer. Let's look at second statement, shall we? In the second statement, they tell us that A is even. A is even. Well, if A is even, then since we are interested in the product of A and B, B would have to be either odd or even. Those are the only two possibilities. A we already told is even. Well, if B happens to be odd, if B just happens to be odd, and fact that A we are told is even, A times B is going to be even times odd. Even times odd, we know 2 times 3 is 6, which is even. And if B just happens to be even, we do not know whether B is odd or even, but if B happens to be even, then again A times B is going to be even times even, which is also even. So it turns out that as long as we know that one of them is even, it doesn't matter the other one is whether odd or even. It does not matter whether the other integer is odd or even. As long as one of those two is even, then even times odd or even times even, in both cases the product is even. So the question was, is their product even? Again, the answer turns out to be yes. Of course it's going to turn out to be yes, because we already found out from the first statement. Then the answer was yes, and the answers never contradict themselves from one statement to the other. But what point here is that the second statement is also quite sufficient for us to be able to answer the question, is their product even? The answer is yes. Second statement is also sufficient. Because of the fact that both of these statements independently turn out to be sufficient for us to be able to answer the question, the answer is D. The answer is D. Let's go to the next one. Number 33. Number 33 says that a certain it says the weights of the dishes of type X are exactly same as the weights of the dishes of type Y. So all the X's are the same weight, all the Y's are same weight. Now where do I find that? It says the weights of all the dishes of X are exactly the same and weights of all the dishes are exactly the same. I think I misread it a second ago. The question simply is the weight of one dish of X, is X less than Y? That's all they're asking here. That is all we have to answer. We know that if all the dishes that are labeled as X are weigh the same, we are also told that all the dishes that are labeled Y are all the same weight. The question is X less than Y? Well, let's find out, shall we? Let's see what they give us. In the first statement, they tell us that the total weights of three dishes of X plus I'm not going to keep reading it. You read the thing in front of you. It's important that you have the book in front of you. Plus the two dishes of Y, we are told, is less than two dishes of X plus four dishes of Y. Let's see what we can do here. We simply want to be able to answer if X is less than Y, yes or no. It doesn't matter whether it turned out to be yes or whether it turned out to be no. We just have to be able to answer definitively yes or no. Let's see what we can do. Let's bring all the X's on one side, bring all the Y's on the other side. That's the logical thing to do. So here we see positive 2X, subtract 2X from here, subtract 2X from here. Here we see positive 2Y, let's subtract 2Y from here and subtract 2Y from here. So 2I's and 2Y's are going to cancel out. That was the whole bloody point. And 3X minus X is less than, and 2X is going to cancel out, and 4Y minus 2Y is 2Y. Now all we know is that 1X is less than 2Y. Is X less than 1? If 1X is less than 2Y, but that does not necessarily tell us if X is less than Y. For example, X could turn, for example, Y could turn out to be 4. Y could turn out to be 4, and I'm going to show you some different scenarios here. And X could turn out to be 3, 4, or 5. If it turns out the weight of Y is 4 pounds, X could be 3 pounds, 4 pounds, or 5 pounds, and in all of these three cases, 3 is less than 2 times 4, 4 is less than 2 times 4, and 5 is less than 2 times 4. As you can see, we cannot tell. X could be, in this scenario here, X is less than Y. In this scenario, it turns out they are both equal. In this scenario, it turns out it's more. So based on what we know, this is not enough. This information is not enough. Based on the fact that X is less than 2 times Y, is not enough to answer this question. A, D, B, C, E. Because the first statement turned out to be not enough, we know the answer cannot be A or D. It would have to be either B, C, or E. Let's look at second statement. We can look at the exact same thing in the second statement and see what we find out. In the second statement, they tell us, that 4X, this is the second statement, plus 3Y is less than 3X plus 4Y. In the second statement, they tell us that the weight of 4 dishes of X plus the 3 dishes of Y, this is how they must have phrased it, 4 dishes of X and 3 dishes of Y is less than the total weights of 3 dishes of X and 4 dishes of Y. Again, bring all the X's to this side, bring all the X's Y to the other side. Subtract 3X from here, subtract 3X from here, subtract 3Y from here, subtract 3Y from here. 3Y's are going to drop out. 4X minus 3X is going to give us X is less than, and this X is going to drop out, and 4Y minus 3Y is going to be Y. Oh, what do you know? The question was, is X less than Y? Well, the second statement clearly tells us that X is in fact less than Y. That's what it boils down to. So second statement is enough by itself, but first statement did not get us anywhere. Because it turned out that only the second statement by itself is enough, the answer is B. The answer is B. Let's move on to the next one. Problem number 34. Just give me 1 second. Problem number 34. We are told that we have a total of 900 students. We're going to have a 3-day fair. Question is, how many attended all 3 days? How many students out of those 900 went to the fair all 3 days? The fair was 3 days long. Out of the 900 students, how many went to all 3 days? Let's find out what they tell us. The first statement tells us that 30% attended 2 or more days. So here's our 900 students. 1 day, 2 days, and 3 days. 2 or more days, 2 or more days. 30% attendance, 2 or more days. 10% of 900 would be 90, therefore 30% is 270. So what the first statement tells us is that out of 900 students, 270 students went to the fair either 2 days or all 3 days. But knowing the fact, but having the fact that 270 students went to the fair either 2 days or all 3 days does not enable us to figure out how many in fact went to all 3 days, which is what we are interested in. How many attended all 3 days? This does not provide us this information. The first statement by itself does not get us anywhere. A, D, B, C, E. A, D, B, C, E. Because we just found out that the first statement is not enough, we know now answer cannot be A or D. Answer would have to be either B, C, or E. Let's look at the second statement. Second statement tells us that 10% of those who attended the fair at least 1 day attended all 3 days. Well, this is interesting. This is interesting because now they are introducing a possibility. It says 10% of those who attended, insinuating that there might be situations where some students may not have gone to fair at all. They have introduced that complication now. So now we are looking at the situations where we have 4 distinct scenarios. Here are the 900 students. 1, 2, 3, and here is the 0. This is the number of students who did not go to fair at all. Let's call them N. N for no days, that is. N stands for, listen carefully, N stands here for number of students who did not go to fair at all. But those who did go to fair, 10% attended all 3 days. 10% attended all 3 days, which means of those students who did go to fair, 90% of X, not N. 90% of them went to fair either 1 or 2 days, but not all 3 days. X represents the number of people who went to fair at all. X represents the number of people who went to fair at least 1 day. At least 1 day. Do you see a problem here? The problem is, by itself again, we are trying to figure out how many went to the fair all 3 days. This does not enable us to figure out all 3 days because we need to know how many people went to fair to begin with. If we know how many people went to fair at least 1 day, we are told that 10% of those people went to all 3 days. But we do not know how many people went to fair at all. Therefore, second statement by itself also is no good. Second statement by itself is no good. Let's try putting the 2 statements together, see where it gets us. This plot is thickening quite rapidly. If we put the 2 statements together, in the first statement, if you recall, we were told that 30% 30% went to the fair. 30% went to the fair 2 or more days. 30% is 270. Does that help? Does it get us anywhere? Well, what is missing here? Can you figure out what's missing here? What is missing here? This guy. Okay, listen to me. If we can somehow figure out, listen very carefully, if we can figure out how many people did not go to fair at all, then the remainder number of people must have gone to fair at least one day. At least one day. Which means we can figure out this x here. And once we figure out the x, we can figure out how many people went to the fair all 3 days, which is the answer is 10%. But that by itself actually does not go anywhere, because what is missing here is this. What I'm trying to make you understand is this. What is missing here is this guy. How many people did not go to fair at all? And putting the first statement together with the together with the second statement is not going to get us anywhere, because first statement makes no mention at all about people not having gone to fair at all, let alone actually giving the value for it. So the two statements together, even if we put them, is not going to do us any good, because what is missing here is the number of people who did not go to fair at all, and the first statement makes no mention of it. The answer here is E. Answer here is E. The questions which turn out to have the answer of E are actually very annoying sometimes. You have to be very careful. Do you understand? Anyway, here the answer is E. Putting the two statements together still does not get us anywhere. I'm not going to start next problem right now because it's on the next page. We'll start a new page tomorrow. Okay? Bye now.